Welcome to Swift Fundamentals. Today, we will look at optionals and how we can use them in code. To begin, let's create a scenario where optionals would be useful. So let's say we were going to create a program for a temperature reader. So we have var temp to hold the temperature, and it begins and it starts off at 80 degrees. And then let's say later on, the temperature goes down and now we're at 75. All well and done. So let's say now that the temperature reader is broken. How would we model that? Well, we would think maybe we could write something like temp equals 0. But in this case, 0 is actually a value. What we're really looking for is something that could tell us, okay, this temperature reader doesn't have a value. And that's kind of where optionals come into play. Now you can think of optionals as a wrapper around another type. By itself, it doesn't exist as a sole type, but rather it's an extension of a type. So what does that mean? So normally you have a type called like an integer or string, and it holds some sort of value corresponding to that type. But when you make it optional, you can also make it hold another type, or rather another value, along with whatever values you expect. So what does that look like? So let's say we have temp2 and annotate that with int. And now we want to notate that this is an optional int, not just a regular int. So we add a question mark next to it. Now I can go ahead and run this, and this will compile, because even though I haven't given it an equal and assigned some value, we can see here that the default value for an optional is nil. So nil is a representation of something not being there, meaning no value. Now, even though it begins with nil, you can also set it to something from the beginning, such as 4. And this also works just as fine. We see that we get the number 4. So an optional basically takes any value of the type that it is. So it would usually be like an int optional, or a string optional, or a double optional, so on and so forth. Basically any type that exists, plus this other value called a nil that represents not having a value. And that way we can start off with our nil, meaning that it has no value, and then later on add something like temp2 is now set to 56. And this will run just fine as well. So it starts off with nil, and now we have 56. Now let's see what happens if we print out what the value of temp2 is. So let's say print temp2 and go ahead. And you see that we get optional 56. And again, because you could think of it as the optional as a wrapper around the number or the value. Now, we probably don't want to be dealing with this optional when we're actually using the value inside. So we have to have a way of, let's say, unwrapping the wrapper, unwrapping the optional. And there are a few ways that we can do that, varying from safety, and we will see what happens in each case. Now, before we move on to that, there is something I want to note, that a string, or rather a type by itself, such as an integer string without the optional, cannot take the value nil, while an optional could take that value nil, as well as anything that suits the type as well. Meaning that our first temp, right, we can write any sort of integer, but we cannot write something like this is equal to nil. Because if you run this, you will see that we cannot assign the nil to an actual type int. However, when it comes to temp2, you can reassign that to nil again if you want to, and that works, as well as anything that fits the integer type as well. So do note that when you are working with optional version of whatever type, or the non-optional version of that type. Great, so how do we deal with unwrapping an optional? Well, the first way that we can do it is something called a force unwrapping. Now this is very unsafe, as you will see later on why. But let's see what the syntax looks like to start off with. So once again, we want to print our temp2. And the way that we force unwrap it is that we add the exclamation sign at the end. And now we just run this. Now we see that we're getting the number 34. So no longer do we see this optional wrapping around it. Now we're getting the actual integer 34. But let's imagine now that this wasn't there. And the last value that we had was a nil. Well, now we get our fatal error because we found a nil while unwrapping an optional value. So this means that we try to go into a value that doesn't exist, and because of that, our program just crashed. This is why it is unsafe, because while here we can clearly see that the last value is nil, so this is probably a bad idea. When you have more complex programs, it's a little harder to keep track of the data that's coming in, or sometimes you're getting the data from the internet, so you're not quite sure what the actual values of that data will be. So if you go ahead and unwrap it, or rather force unwrap it, you may run into this error. And this is a runtime error, which means that the error occurs when you are actually running the program. So imagine you're opening an app and suddenly it just crashes and closes on yourself. You as a user wouldn't really know what's going on. And that's not a very good look for your app. So this is just what is known as a runtime error. And you want to try to minimize this as you can. And in this case, force unwrapping is the cause of that. So you don't want to really go about it this way. You want to use force unwrapping maybe during a testing phase, or just writing something that you are going to be testing at the moment, or you really know what the actual value is. But more often than not, you will use some of the other ways of unwrapping, which is a lot more safer and more secure around your program. Before we move ahead on one of those, I do want to point out for those that are probably thinking it, you could use control flow to mitigate some of this, meaning that if you could do something like if temp2 does not equal nil, then you want to do this print over here. Else, I don't know, you can write a message for yourself, like print, whoops, that's the wrong thing. We can say print, there is a nil, and this will make it a little more safer. Though your way that you're unwrapping is still unsafe, you just added control flow to handle that a little better. But it's still not the swiftiest way of writing it, meaning like you're not leveraging all of the things that Swift has to write concise code. So do keep that in mind. While this is a way that you can work around it, there are better options at your disposal. Okay, so if force unwrapping isn't the way to go about it, then what is a better option? Well, that's when we get into binding. So what binding looks like is that you essentially try to store this optional into another variable if possible, without it being an optional. And if you can, then you do something. Otherwise, you do something else. Now, by that statement, you should probably think, okay, it probably will use control flow, and you would be right in that. So once again, we'll use temp2 as our example. We will write if, then let, meaning we're declaring a variable. If we can declare the variable temperature2 out of temperature2, now this one right here does not refer to this one over here. This is our new variable that we're creating for this code block from here to here out of the optional that we have here. So this variable over here will only create if the value in here is not a nil. If we go ahead and check what this is, we will see here that the type is int, not optional int, as opposed to this one, which if we check, we see that we have optional int. So this one right here refers to this up here, and this one is just a new variable that will only exist within here to here, our code block essentially. So if possible, then print out whatever temp2 is, right? And again, now this one refers to this one, not this one or this one over here, okay? The colors help. This green coloring helps for you to know that, okay, you're talking about these and these two are talking about each other here. Else print there is a nil. So now let's comment this out and let's run this. Now we see that when we get here, we obviously cannot make the variable temp2 because what we're getting here is a nil. And so we skip over and we just go to our else statement. Now, if we bring this line back over here, meaning that it will have a variable, or rather it will have a value in the variable, we run this and we see that our 34 gets printed out, and 34 without the optional wrapping around it, which is the key thing that we're trying to do. This is called binding. Now, if we had multiple optionals, let's say we also had an optional over here called var condition, and we'll set that to a string optional. And then the condition was sunny. Whoop. Now, let's say for your readout, you want to make sure that you have both things, a condition and a temperature. Well, you can go ahead and just put a comma here, and we can write let condition equal condition. Once again, reiterating that this condition on the right-hand side of the equal sign refers to the optional, whereas the left one is just our new variable that exists solely from this code block, or rather in this code block. And then we can just print out temp2 and whatever condition is. And so let's run this. And we see that we get 34 and sunny, which is not wrapped in these optional wrapping when it gets printed out, because we've binded it to these new variables that exist over here that are wrapped unsafely without a problem. Because if there would be a nil, let's say in condition, it would skip this whole thing and just go to there is a nil, right? So sometimes we require multiple optionals to be there to do a certain thing, and we cannot move forward if we don't have all of them. And this is how you would write that. Now, if you have separate things to do with these optionals separately, you would then split this up in different if else statements, or rather if let statements as needed. Now let's imagine that if we had one of these and we wanted to print out like temperature, but if we had both, we wanted to print both out. Well, then we can nest these bindings, something like if let temp2 equals temp2, and then if let temp, or rather condition is equal to condition, then here we want to print both of these out, sort of like what we had before. However, if we don't have condition, well, then we can just print out whatever temp2 is, right? And so here we have nested it rather than making it a condition rather than making the condition be that both of them have to be unwrapped, like above. Here now we have a little more control flow to control what exactly happens. If we only have one, well, then the temperature gets printed out. But if we have both, then both get printed out. So let's test this out. And we see now that we get only temp because condition is set to nil right now. But then if we take away this comment and we put sunny back in, we see that now we get both of these printed out together. So just another way of controlling binding a little further than just putting them all together, such as we had here above. Now, just like we can do conditional binding with control flow, we can also do it with a loop, specifically a while loop. So let's go ahead and build an array as we've seen before. Let's say var my array and set that to some numbers. So let's say 43, and then let's have 6, 74, 8, 23. Okay. And now we have something called pop last. So before I showed you guys how to access the last element using an index, using the count and minusing it by 1. But there is also a built-in method called pop last, which gives you back an integer, or rather whatever type it is, but an optional version of that. Because what it does is that it pops the last element, but the people that have written this wrote it so that you can get an optional back, because there may be a scenario where, let's say, there weren't any values, it would be an empty array. You can't pop last something that isn't there. So in order to have some sort of return, they give you a nil instead, right? So now that we know how to deal with that, we can simply write something like if let last equals this, well then just print whatever last is, right? And that's using conditional binding as we saw before, so you get 23 as we had before. But let's say we wanted to pop everything until we got to the end, And once we had no more values, we want to stop and just stop there essentially. Well, we can also use, instead of writing if let last, pop last, and doing it over and over again, we can create a loop, a while loop. So we'll write while let last equal my array dot pop last. So essentially, while you can keep getting a value out of pop last, just print out what last is. And we see here now, rather than just getting one value, we get 23, then we get 8, then we get 74, then 6, then 43, and then finally we are done. So this while loop ends. The conditional here is if you can get an actual value out of the pop last, then keep going. That's what this Boolean statement is basically amounting to, right? Your Boolean condition that you're getting to power the while loop is if you can make a variable out of this result. And if it's a nil, then you can't create that variable. And so it stops the loop. Just something to note moving forward. Now, this is a good time to introduce a guard statement that can exist inside a loop or a function when we see those later on. And a guard statement, essentially, all it does is that it makes sure that something is being met before moving forward. Otherwise, it stops whatever we're working on. So let's say that we had this while loop over here. We can add something called a guard statement saying guard, whatever last is, needs to be, let's say, less than 80, or rather less than 70. Else, you want to break. You want to stop this loop. Okay, and then we want to print out. So essentially, we want to print out things that are less than 70, and if they're not, then we want to stop the loop altogether. Well, if you run this, you see that we get 23, we get 8, but then because we get 74 and the guard is not met, it goes to the else and it breaks away. Guard statements are like an inverse if statement, where it doesn't give you a code block to do things. It just assumes whatever's underneath is the things that will be executed if this is met, if this is true. And then you have an else right next to it that essentially gives it some sort of break out of the loop to stop or a continue or something of that nature, or return when we see that in functions. So why is this useful? Well, because guard can also be used to bind a nil value. So just like we have optional integers, optional strings, we can also have my optional array, where the array is going to have integers that are optional. And because of that, that means that now I can set this to have something like 65. It can have a nil. It can have another number, 5, and nil. Right? And a way that we could handle that is that we can simply say, okay, for number in my optional array, this time I'm using a for loop. So because I'm not going to use the while let example, here what I can do is write guard let number equal number. And again, this num now refers to this one here, which is each individual number here. And now this is going to be what exists underneath the guard statement. Else, just continue. So move the loop onto the next element. And if we do have a value, we'll then just print we have, and then let's give it num. And I'm getting an error here because, oh, right, this is an integer. So once again, we can use description to turn it into a string. And now we have 65, we have 3, and we have 5. Right? So it has this is an actual value, num can exist, so it prints it out. Then we get a nil. Because this isn't met, this doesn't hold true that you can create a variable out of that nil. It goes to the else statement, which is a continue, which we remember from last lesson, means that we just move forward with our loop to the next value. and so on and so forth. Now, there is one more way that we can unwrap an optional, and it's a lot more safer, but a little more niche in its use. And this is something called the Nil Coalescing Operator. So what does that mean? It means that we can go ahead and say var test is an optional string, for example, and then say let name equal test, and then we write these question marks and put a value of the same type that will be used in case this is a nil. So let's say Al. And let's run this. And we get Al over here. So if we check what print name is, we get the string Al. And that's because test is resulting in a nil. And the way that this works, the way that the Nil Coalescing Operator works, is that it basically tests whatever is inside the variable and see if it's a nil or an actual value. If it's an actual value, then it will just use that value, set that to the variable. However, if it doesn't have a value and it has a nil, it defaults to whatever you want. So there'll be situations where you basically want to set like a default value to it if it has a nil, and this is the way that you would do that. So let's imagine that there was something there, Ken, and we run this. We see now that what we get actually back is Ken because it tests whatever was inside, saw that there was a value, and it wasn't a nil, so it set that to the name and then prints that out, and it does not use this default value. And we can check that the type is just string because it can assure itself that it will never be a nil due to having either a real value here or whatever the real value will be on the right side. So you can't put a nil here. You need to put an actual value of the same type. So yet another way that we can unwrap this optional safely. And that basically wraps it up for optionals. There are some things that you may want to keep in mind, such as like when you're testing optionals. So if we have something like if test equals, let's say Bob, then print it's the same name, and we can run this, and you can see that you can test for, well, let's just do an else so there's something visual that we can see. Print it's not. So we can see that we do not need to unwrap an optional to test for equality. So do keep in mind, though when you are testing for equality, you may get some interesting results, such as if you have, let's say, let's erase the Ken, and we set var second test to another string. Right, and you may be wanting to test for if they have the same string, or if they have the same test name or something like that. But if you write something like if test equals second test and print out the same name, you will see that you will hit this print statement because a nil equal to a nil is true, right? So do keep in mind that there are some things you have to consider when you're comparing optionals. But the takeaway here is that you do not need to unwrap if you want to test against an actual value. And then if you test two optionals, do note that sometimes you may be thinking like you're testing for the actual values to be the same and not considering that a nil and another nil are equal in equality. So keep that in mind.